Good morning, ladies of calculus. Welcome again to room 15 where Larry never ends. And
Is that a glue stick?
yeah, that's an artifact of misbehavior during another period, so I'm leaving it there for a purpose. Thank you for recognition of that.
Okay.
What we're going to do is, it wasn't this period. Thank you for being grown up enough not to do stuff like that. Thank you for that.
No problem.
And your parents. I appreciate that. Okay. Anyway, what I did yesterday after school, I went and made a video that went over several of those types of problems. The pen I was using was a little bit glitchy, so you have that as a resource for you. Did anybody look at any of those problems yet?
Not yet.
That's good, that's good. So you have some chance to do that. That's good, that's the way it was designed. So let's go ahead and look at this one right here. Now this one here, it says f double prime of x equals 2 and f prime of 1 equals 4, f of 2 equals negative 2. So what in this, I'm going to solve the following differential equations. What clues do you have that tells you what you need to do with this thing? Anything? Okay, let me go ahead and explain. What happens is, when you see this here, when you see differential equations, what this means is you're going to do something, and you're given this function here, where you have f double prime of x is equal to 2. What that is telling you is that you're going to want to integrate to find a general solution, and then you're given these points of data here that you're going to use to go from a general solution 2a, 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 2a.
Huh?
Let me repeat. You have these points you're given to go from a general solution to a particular solution. Thank you. Okay. So what we have is we have something called f double prime of x. You can do that as we'll say dy dx is equal to 2, and what's the next thing going to be here? Something first. What first? Yeah, move dx up here, right? So we have dy equals 2 dx. What's next after that? Yeah, these are called integrals right here. So now if we do that, what do we have on the left side now? Y. And the right side we have 2x plus c. And what are we going to do next? Yeah, and what it is, we're going to go ahead and in recognition of where we are. We went from f double prime to f prime of x. Okay, and so now we're going to make use of this, right? So we have 4 is equal to, plugging 1 in place of x, we have 2 times 1 plus c. So c is equal to? C is equal to 2. And so what we have is our particular solution. I'm going to write down here is we go ahead and take this thing right here. So we have f prime of x is equal to 2x plus 2, right? 2x plus 2. And so now what are we going to do with this guy?
Same thing with that equation?
Yeah, same thing, right? So I'm going to put dy dx up here equals 2x plus 2, and then
Put the X on the other side.
Yeah, dx. So we have dy equals 2x plus 2, we'll say dx, and then, so we have y is equal to the integral, we'll say 2 integral x dx plus 2 integral dx, right? And then what?
It can be 2x squared.
Yeah, so you have 2 x squared over 2, so that's going to cancel out this 2. Does everybody see that?
What? Yeah, so it's just x squared.
Yeah, so what you're going to do is this one right here. I'll just go ahead and write all the steps and make sure everybody understands. So you have x squared, but you divide by 2. So that's going to cancel that out, right? And then plus 2x plus c. And then
Plug in.
f of 2 equals negative 2. So we have negative 2 is equal to 2 squared plus 2 times 2 plus c. And so that's 8, isn't it? Is that 8? Yeah. So we have negative 2 equals 8 plus c. Is that right?
Yeah. So C equals negative
So c is equal to negative 10. And so therefore our particular solution is f of x is equal to
2.
x
X squared
squared
plus 2x
plus 2x
and minus 10.
minus 10. And then if we differentiated this thing twice, where would we end up?
With
We would end up here, wouldn't we? And you can just test it, right? You take first derivative of this, we would get 2x plus 2, right? And so that would get us to here. And take the first derivative of this, we would get 2. So there we are. Okay. Now I want you to go ahead and do problem 26. And it should be,
26.
yeah, 26, right? Can you do 26? That's your f double prime of x equals 2x. And that's f prime of 2 equals negative 1, f of 3 equals 1. Yeah, it's the same type of problem, except this is 2x, and the numbers are a little different here. I'm just leaving this out here to make the room. What I did, even in a problem like this, the arithmetic wasn't too advanced, was it? But still, even with that, were there a lot of opportunities to make mistakes?
Yeah.
I caught myself when I was doing that video for you yesterday, that I caught myself saying at least a couple times, well, I'm not sure if this is 100% right. Please let me know if I made a mistake. Does that sound familiar? Yeah. How are are you helping each other on this? I see some people, looks like everybody's doing some, we're gonna make sure we help each other to understand how it's going, okay? And we'll get to the learning pyramid. Let me see. While you do that.
Oh, that's what I should have done. But I had first. Yeah, oh, yeah. Actually, that's great.
how are you doing on this one?
We finished it.
You finished it? I'm gonna tell you what I got as an answer. I don't know if it's right. Tell me if it's right. I'm gonna write it down here. I got my particular solution here. I got f of x equals x cubed over 3. Is that right so far?
Yeah.
Minus 5x and plus 7. Is that right?
Yes.
Is that right?
Yes.
Okay, do you have questions how we got there? Anybody? The second part? Let's go ahead and fill in. Can somebody, anyone else? So if you can explain to her, somebody, how to get her unstuck. Is anybody else stuck? Are you stuck on it too? Where did you get stuck? Okay, so we did this one, right? So what we're gonna do is take the integral, we're gonna anti-differentiate this thing here to get to the next level higher. So we're gonna go from the f double prime up to the f prime level. And so what we do is I'm gonna rewrite this one as dy dx is equal to 2x. Okay, I just replaced that. And so now, just go ahead and cross multiply. We have dy is equal to 2x dx. Okay, are we okay? We're okay there? Okay, good. So now we're going to take the integral of both sides of this. So what we have here is y is equal to 2, and we're going to, and the integral of x dx is going to be x squared over 2 plus c. Okay? And this cancels here. Right? So we're canceled right here. And now, what are we going to do with this one? We're going to make this, we're going to change this is f prime of x, right? Here's your f prime of x formula there, which equals y equals that. And what do we do next? We substitute this guy here. So f prime of, so we're going to take this, so we say -1, which replaces this f prime of x equals 2 squared, right? Replacing that x here with 2 plus c. And then if and we're going to subtract, so we have -1 equals 4 plus c. So therefore, going to the right, subtracting 4, we have c is equal to -5. So now we take this -5 and go right here like this. And so we've gone up one level from f double prime to f prime, and this is called our particular solution. So it's going to be f prime of x is equal to x squared minus 5. Okay? So that's the first level. And now the next level, and already there's enough little arithmetic calculations that already I'm not 100% sure this is right. And that's why I did this on the side, I put the answer there to see if you got the same thing. But, so now I'm going to write this as dy dx, and that's going to be equal to x squared minus 5. And now distributing the dx, we have dy is equal to x squared minus 5 dx. Okay? And now the integration. So we have y is equal to x, well, I'll say x cubed over 3 minus 5x plus c. And the final step is to take this thing right here. So we have 1 is equal to 3 cubed over 3 minus 5 times 3 plus c. And this over here on the right, still have 1. This simplifies to 27 over 3, so that's going to be 9 minus 15 plus c. And then, so that's going to be negative 6, so 1 equals negative 6 plus c. So c is equal to 7. And then we take the 7, plug it in for this one, and we end up with f of x equals x cubed over 3 minus 5x plus 7. So that's where that comes from. So a lot of things. Just a lot of little things there. Okay. Okay. What I want to do is we're going to go to this one where it says sigma notation, and it's going to be in your packet there, and we're going to go over this pretty quickly, and it's mostly going to be putting things in your calculator. Sigma notation classwork, and it says here's the problem, and sigma notation is another way of writing an integral, kind of. It's not the one we're going to use mostly in this class. And one reason it's kind of rounding out your calculus thing. So it says find the following sums, and it says, and we're going to use the calculator for most of these. Find the following sums. So let's get to one. It says find the following sum, calculators allowed. So can you get to this right here? Are you there on this? So we're just going to...
On our packet or?
In your packet, yeah.
Yes.
You have this in your packet? Okay, I want to show you how to do this in your calculator, and you might have remembered this from last year. I don't know, but it's in your calculator. So in your calculator, what you do is you go to Math, and then I think it's down here. Sometimes I have to go searching for it here. I'm going to scroll down. Yeah, this summation. So Math 0. All right? So you go to Math 0. So we'll get right here. So we start out, it says, it says I equals 1. Well, you're at the liberty to use whatever letters you want. So sometimes, just to make things easier, I'll use X. So you can use an X key. So you can go X is equal to 1. And then you're going to come up here, and what number goes up there? I have trouble remembering. 7? Yeah, so 7. So 7 will go here, and what's going over here? 8? 8x? 8x, yeah. So you got to make sure whatever letter you use. Now they use, typically, it's more conventional to use I and J and K. You remember doing that last year on the calculator in pre-calculus? No one does? We tested it the first semester, so it's been over a year since you've been tested on this. So you press this, and you get 224. And so what is the process that's making this happen? What is the calculator doing to spit out 224? What does that summation mean? Okay, I'll tell you what it is. What it's doing is it's going ahead and taking 1 and replacing x with 1, and so it's so you have 8, right? If we replace 8 x with 1, we have 8 times 1, which is 8. Then, so you're storing that 8 over here. Then you're going to go up to 2. So then you plug in 2, 8 times 2, which is 16. And so now you have 8 plus 16. You do the same thing for 3. You plug in 3, so you're going to get 8 times 3, which is 24. And you put that at the side. So now you have 8 plus 16 plus 24. So that would be 1 for x equals 1, x equals 2, x equals 3. And you keep on repeating the process until x equals 7. And so that's what it does. It adds, it sums all that up. That is a summation symbol. So that's what the thing is doing. So I don't think we need to spend a lot of time on this, really. So what I want you to do is take, just work out this row of, can you do that? This first row here.
Put the brackets in there, or is it going to do it itself?
Yeah, what I would do, I'll tell you what I would do for brackets. I would just make them a parentheses. So you'd end up putting a parentheses, I plus 2, close parentheses, open parentheses, I plus 3, close parentheses, close parentheses. Does that make sense? Yeah. So just do that. Because and one reason it logically flows in that what we're doing with integration is we are doing summations of infinitesimally skinny rectangles to come up with our area under a curve. Okay, any questions about that? If you have questions, you're able to help each other on that pretty well? Okay. Does anybody remember anything about this in pre-calculus? Okay, Emma remembers a little bit. Anybody else? A little bit. So it's back there in your mind someplace, even though faintly, but that's common. When we did this last year, we spent very little time at it last school year. It was just before the first semester final that we worked on this. Sigma notation homework, we don't even need to do that. Okay, we come here to note card 40. So I want you to kind of clear out your attention span a little bit. How do you clear out your attention span? Stand up, pay attention to something else for a minute, because I want you to be focused on this. Okay, are we ready for this now? Everybody's ready? Okay. So one thing this does is we really address this in that commission song you had me help write this year, this calculus song, where we have PVS or with definite integrals with lower upper boundaries. We find the area underneath the curve. So this is exactly what we're talking about here. With lower upper boundaries, we find the area underneath the curve. And with the finite integrals. Now, what we've been doing up until now, and what the homework assignment you have in hand, is what we call an indefinite integral, where you have to add the C. And so that's addressed another place in the calculus song, which is going to be right here. Never forget to add the C. Oh, right here, right? With indefinite integrals are solutions general, so we should never forget to add the C. But if there's a point that we can use, we substitute for x and y. With C solved our solutions particular. They're like too many syllables for the thing, but that's what it is, right? And that's what we did. Isn't that right? But here, what you're doing here is you're actually given the boundaries. And so you don't have to, when you have these boundaries in place, and this represents a region bounded by the x-axis and vertical lines x equals a and x equals b, and says it's always positive. So just a quick sketch of what that looks like is you have the sketch of a function right here, okay? And what you have here at a and at b, and this is going to be our function f of x. So what we're doing is we're taking these vertical lines here that are going to separate off this area, and this area between a and b is right here. So that's what that is. This is the integral from a to b of f of x dx. That's what this whole area is here. Remember I showed you the Foxtrot cartoon thing with Bob's vegetable garden? Remember that?
No.
You don't remember that? I'm going to show you that because it's funny, it represents. Because what happens is we're trying to make this thing Foxtrot. There it is. Foxtrot cartoon, Bob's vegetable garden. Because I've showed this to you before, but I showed it to you before we worked on integration like we have. So basically you have the Foxtrot has this main character is Jason Fox, and Jason is this super brainy, nerdy kid who makes up a calculus problem out of he's a type of kid that is he wants to get the hard problems. That's the way he is. I don't know, do we have anybody in here like that? Maybe a little bit sometimes. You're that way? I'm that way sometimes. But I don't have it thoroughly steeped in my total character. I'll say that much. There we are. Remember seeing this cartoon?
Never.
You remember seeing it?
No.
Okay. Well, good. So anyway, here we have Jason. He's here. He's given this thing word problems. Nothing but word problems. He turns his eyes heavenward. Thank you. And it says, here's the problem. Farmer Bob's vegetable garden is 20 feet wide by 30 feet long. Calculate its area in square footage. And so here we have this area which is 20 by 30. And so he decides to make a calculus problem out of it. He lets y equals f of x equals 20. So here's y equals 20 right here. And we have this thing from a to b. And in this case, a is 0. B is 30, 20 dx. And then he takes the first derivative of the integral of this, and the integral is going to be, what's the integral of 20 dx? It's going to be 20x, right? And he's going to evaluate from 0 to 30. And this notation that he does here in the cartoon is what we're going to be doing here shortly. And he goes like this, and he gets 600 feet. And then he says, he says, call me Mr. Rigorous and all this. So he makes a calculus problem out of a simple area problem. But basically what we're doing when we do calculus, we are actually, it may not seem like it, but we're actually making problems this easy. Even if it's a curvy function, which we're going to mostly see, like this one here. We're doing it because of the technology of calculus. Makes it like Bob's vegetable garden problems. So here we have it. It says set up a definite integral that yields the area of the region, denoted by f of x equals 9 minus x squared. Do you know what 9 minus x squared looks like? I've talked about this a few times in this class, and last year in pre-calculus we briefly talked about it. Do you know what that function looks like, square root of 9 minus x squared? Does that look familiar to anybody? What kind of a shape does that make? It's going to make a half a circle. It's going to make a half a circle. And so what it is, the circle, basic circle equation is this one, x squared plus y squared equals r squared. And if r is 3, we get x squared plus y squared equals 9 for r is 3, right? And so we get y squared equals 9 minus x squared. And so y is going to be equal to plus or minus the square root of 9 minus x squared. And so what this is the plus side of that. So we're talking about just this semicircle. So sometimes in calculus, what you're going to have is you're not going to maybe know how to integrate this, but you know what the shape looks like. You know it's a circle with a radius of 3. So what is the setup of this? Well, your area is going to be, how do we write this? Our area is going to be equal to, we got negative 3 to 3. How do we set that up as a integral? What are the boundaries of integration here? Negative 3 to 3. Okay, so we put negative 3 to 3. And what function goes here? 9 minus x squared. And so dx, right? And what is the answer to that? What is the formula for area of a circle? Yeah, so pi r, we know that r is 3, right? And it's half a circle, so over 2. So we know that our answer is going to be 9 halves pi. So that's going to be our answer. So you see, when we have our definite integrals, we don't have a c, do we? Because we know what it is. Exactly, so that's the right answer. Now we didn't use a power rule of integration or anything, but to do it this way, we had to know what? We had to know what the shape was, right? So we knew what that was. So that's going to be our answer to that. So occasionally you're going to be given equations like that where you'll be able just to do that without using the rules of integration, because it'll be a shape you're familiar with. So now we have this one here, the linear piecewise function of the right. F has the given points and is defined for between negative 2 and 3. And what is the value of negative 2 to 3 f of x dx? Now, we've talked about this in terms of this class a little bit here, that if this was a function, let's say f of x was, instead of, let's say it was v of x, like the velocity, what would the area of this be? If f of x was the velocity, if this is a function of velocity, what would the integral be? What kind of units would it, let's say this is going to be feet per second in units. What would the units be of our answer of the integral of this? What would the units be? Okay, I have this introduced another little song. Here in AB calculus, in order to be great, don't hesitate to eliminate the rate. To eliminate the rate, you need to integrate. Integrate, integrate. You really can be great. Well, so what are you going to do to eliminate the rate?
Integrate.
Integrate. So what are you going to have left after you integrate? If you eliminate the rate, what are you going to have left as units?
Feet.
You'll have feet. Okay, so you'll get rid of the per and just have the units there. So that's just something that's going to come up in a real world application. So I've just got a previewing that. So what do we get for our answer to this? Well, the answer is this area. And what do we do with this area down here? What do we do with this area down here? We will subtract it. Thank you. Okay? We will subtract it. So if you can just find the area of, you have the area here of a triangle minus the area of this little trapezoid, that is going to be your answer. So we have 1/2 base, and our base is going to be, is that going to be 3.5? Times our height, which is 3. And we're going to subtract out this thing right here, and it's going to be, your trapezoid is 1/2 the height. What is the height going to be? 1. And then we're going to have base 1 plus base 2, so that's going to be 1 plus 1.5, right? So that's what it's going to be. I don't know what this is worked out, but this is the answer, right? That's an unsimplified answer, but it's an answer, right? So can we just call that good? Okay. And what we're going to do is I want you to hand in your homework assignment first thing on Monday morning. If you have a question about your homework assignment, what are you going to do?
Look at the video.
Look at the video. If that doesn't help or work, what are you going to do?
Ask a friend.
Ask a friend.
Or come to you.
Come to me. You can email me, and I'll be responsive about that, right? Okay. Everybody has my email address, right? Yeah. Yes, it's 6:40. We'll come to 6:40 next.